So once we have calculated all memberships, we can then use the membership to calculate the centroids. So you can see that once we have get all the membership values, since we have two clusters and we have 7 points, this is going to be our 2 by 7 membership matrix. How do we use this matrix to calculate the centers? So you can see that we use it through this formula. The formula for the numerator and denominator, they have a common part, which is the denominators. So you try to sum up for every single membership, you take the m value. If you still recall the m value is the one that we use the same over here. So we try to use the same value to calculate our membership as well as to calculate our centers values. And therefore, like I mentioned earlier, m is by default set up as 2, and that's what we will use in the center calculation. And therefore, you can see that while we try to calculate the very first row of the membership or the first cluster, you can see that the first values are 98.78, 100%, 98, 50, 10, 2, and 0%. While we're doing that, we use for the denominators, we have 98.78 with the square plus 100% square plus 98% square plus 50% square plus 10% square plus 2% square plus 0% square. So that is how we can calculate for the denominators. For numerators, we use the same value, but you can see that for every single one, before we want to sum up, we want to take each member's location into consideration. So you can see the higher percentages of the member, it will contribute more to the new center generation. And therefore, take a look at this one. The first node is at the location of 2, so 98.78% with the square multiplied value of 2. So that's how much it has contributed to the first cluster. For the second node, it's 100%, which is the center itself, will multiply a value of 3. So you can see that the next node is 4, the next node is 7, the next node is 9, the next node is 10, the next node is 11. And therefore, if we multiply all of them and then sums up them together, we will get the new center equals to 3.327. So that is the update for the first centroid. It moved from the location of 3 to 3.327. We can do the same thing on the second centroid of the cluster by using the lower row of the membership. So you can see that we do the same thing for 1.22% square plus 0% square plus 2% square, 50% square, 90%, 98, 100% square. So we sum all of those values up. For the numerator, it's the same thing. Each one has the contribution. So you can see that the node 2 has very, very small percentage. And after the square, is almost nothing over there. But it contributes a little bit to the the second cluster. And you can see that the more percentages, they will contribute more to the cluster. So in the end, you will get a value of 9.814. So it has moved from the location of, what's that? Let me see. It's moved from the location of 11 to 9. So yes, it actually moved to the left side of the location of the cluster. So you can see that's how we will be able to reuse the membership and then calculate the center for each cluster. And therefore, you can see that the equations, if we look into the pseudocodes again, initiate the membership function. And for each step, in the beginning, we randomize a location. So we don't really need to do this in the very first step. We randomize a location of 3 and 11. And then we calculate the membership. Based on the membership, we can recalculate the center. And we can check the new center versus the old center, are they close enough? If they are close enough or they don't move at all, then we can stop. Otherwise, we go back to step number 2, use the new center, calculate the membership function, and then look for the new locations. And that is how we will be able to do the Fuzzy-Siemens clustering. While I'm preparing the slides, I want to show you a little bit of the tricks when I'm doing the calculation of the membership. So what I use is actually, I use the Python. So if we look into the Python we have an interactive window for me to use. So what I'm trying to say is, what I'm trying to show is that when I'm calculating the values one by one, of course you can use the calculator to do the calculation. But for actually computer science people, we are actually relies on the programs pretty much a lot. So if I'm going to, for example, calculate the denominators, what I'm going to do is that I can simply use 0.0122, which is that value of 1.22%. And because it's square, we can use the sqrt function, but for simplicity, we can just type in one more time and then plus 0% square. So, okay, 0 times 0 plus 2%, 0.02 times 0.02 plus 50%, 0.5 multiply 0.5 plus 0.9 multiply 0.9 plus 0.98 multiply 88 plus 1 multiply 1, and we will be able to get the value for the denominators. And of course, if you want the numerators, we can use the same values by adding the data points of each value. So multiply 2, so that's what we can cover. 1.22% square multiply 2. And then the next one, 0 multiply 3. And then for the next one is multiply 4. And this one is multiply 7. And then 0.09 is going to be able to multiply 9, multiply 10, and multiply 11. So that we can use the software to help us, not really the software, but the program to help us calculating the values. So this is just showing you how it's easier way to do the calculations. And of course, the reason I'm showing you that is because I want you guys to have some practice. So this is what I want you guys to do for the assignment, and you need to submit it by the beginning of the next class, which is going to be April 7th. So use the fuzzy-Siemens clustering. I want you to go through the whole process for one time. You don't need to repeat and complete the whole fuzzy-Siemens clustering, but at least I want you to have the experience to go through every single one of that. So I'm going to give you the same data set, the initial centroids, instead of the examples we use, which is 3 and 11. I want you guys to use the initial centroids for the value of 4 and 7. So you use 0.4 as the initial centroid. Another cluster is for 7. So you still have 2 clusters with 7 data sets. So I want you to calculate the membership function, and I also want you to calculate the next iteration's centroid location. So prepare that one, and I want you to submit it through the Blackboard. So basically, that is all I want to discuss for the class today. And check the announcement and see if there's anything that you need to be prepared. See you.